This video goes over calculating probability using combinations. So before, we talked about permutations and combinations for counting, and now we'll use those combinations for not only counting, but probability. Let's review some definitions. First, a permutation, we have to meet criteria where the objects are distinct, repetition is not allowed, and order matters. And then we have the formula for permutation. We can also put that in our calculator and not use the formula. For combination, the objects are again distinct, repetition is not allowed, but unlike permutations, for combinations order does not matter. Again, the formula is given, or we can put this in our calculator. And since this video covers finding probability, just to review the definition of probability, the probability of an event E is the ratio of the number of ways E can occur over the total possible outcomes. Let's look at a few examples. The first example, you have manufactured calculators, and suppose that due to a manufacturing error, a box of 10 calculators contains 3 defective calculators. To test your quality control department, you have a worker choose 2 calculators from the box. So in this box of 10 calculators, we want to find what is the probability that your quality control department chooses no defective calculators. Okay, so first we have to think about, well, how many are defective and how many are okay? In this box of 10, because we have 3 defective calculators, that would make 7 that are good or okay. So the question asks again, what is the probability that your quality control department chooses no defective calculators? So that means we want to find the probability that we choose 2 good ones and 0 defective ones. Remember again, we're only choosing to test 2 calculators from the box. Because we only care about the calculator being defective or not defective, we don't really care about order. We're picking 2 calculators, so we're not going to have repetition, and that makes it a combination. So our first fraction, we've got 7, choose 2, meaning out of the 7 good calculators, we want to choose 2 good ones. And out of the 3 bad calculators or defective, we want to choose 0 because we don't want any defective calculators. In the denominator, remember that probability is always out of the total amount. So we have 10 total calculators that we could choose from, and we're choosing a total of 2. Also notice that if you look at the front numbers, 7 and 3, they add to the front number in the denominator, 10. And if we add the back numbers, 2 and 0, we get the back number in the denominator. Okay, so plugging this into your calculator, we're going to do 7 choose 2, 3 choose 0, and 10 choose 2. Again, I'll just use my calculator. So for 7 choose 2, we get 21. 3 choose 0, we get 1. And 10 choose 2, we get 45. Multiplying, that gives us 21 out of 45. And because we don't really want a fraction, you wouldn't report a fraction to a friend, we can say that's a probability of about 0.47 rounded. Okay, so let's take the same example, but this time we want to find what is the probability that your quality control department chooses all defective calculators. This is kind of the opposite of our last example. So remember, we still have a box of 10, 3 are defective, so it still means that we have 7 good calculators and 3 defective. So again, the question is, what is the probability that your quality control department chooses all defective calculators? We're still choosing 2 from the box, so we want 0 to be good and 2 to be defective. Just like before, we don't really care about order, so I'll use combination. So out of the 7 good calculators, we don't want to choose any of those. Out of the 3 defective calculators, we want to choose all 2. The denominator is still 10 choose 2 because we have 10 calculators and we're only choosing 2 from the box to test. Putting all of those in our calculator, we get 7 choose 0 is 1, 3 choose 2 is 3, and 10 choose 2 is still 45. So multiplying, we get 3 out of 45, which gives us a decimal of 0.07.